Yeah, comes on everyone. Let's start off. Let's see. This was the last thing that we are discussing. I hope now it is clear why it is this thing. I sent it. Did everyone look at it? Just to brief it again, this is what was happening there. See, end of the day, the string doesn't know how many waves are there. The string will simply think on the left string, there is an incident wave and there is a reflected wave. And on the right string, there is only one transmitted wave. Getting it, all three waves are not acting at the same point, they're acting on two different strings. So if you take 2 points pretty close to it, like one close to this and one close to this, since both are attached, this wave got displacement and this combination got displacement should be same. Getting it? So that is the reason that y incident plus y reflected is becoming y transmitted. That was the thing. Clear? When you have a calm mind, you'll figure it out. In the middle of the class, you can't figure out something new. And after the class, I was thinking, we are so dumb. We didn't figure it out. But okay. And then I think remaining is all fine. Now the next thing, the important one, is a stationary wave. Others switch on your cams. Who is missing? There are 4 people who are missing. 3 people are missing. Okay, let's start off. Stationary wave or standing waves. Now, when two waves of same frequency and amplitude moving in opposite direction are superposed, we observe certain points on the string do not move. We call them nodes. And certain points move with double the amplitude. We call them antinodes. Now, what do you mean by this exactly? Now, listen to this carefully. Yeah? It's more of an observation. If you figure that out, then things will fall in place. Let's say we have two waves traveling. Meaning there is a wave here also, but I'm just showing that part. There is a blue color wave here also, but I'm just showing the left hand part. Now let's try to observe this point here and see what happens. Now, this red color one is a wave which is traveling towards the left, and the blue one is traveling towards the right. They have same speed, same amplitude, everything same. Only thing is they're going in the opposite direction. Now, you'll observe at this instant, the red cut displacement and the y cut displacement both will cancel out. You end up with displacement of A is 0. Isn't that how we add the displacement of red plus the displacement of the blue? In this case, both are 0, so it is 0. Next moment, if you see this red one would be something like this. And by symmetry, you will see the blue one must have gone this way, must be something like this. Now you'll clearly observe here again, the red one is pushing it up by this amplitude, the blue one is pushing down by the same amplitude. You will observe the A is again 0. Next moment, you will get a full wave here. And this blue one would be like this. Again, you'll clearly see the blue is pushing down, the red is pushing to maximum amplitude. Again, the point A is not moving. Meaning you can just keep waiting for how much ever time you want. No matter how much time you wait, you'll observe the red and the blue will always cancel at A. Are you getting this? So you'll observe when these two waves are passing through this thing, this point will never move. Similarly, if I go ahead, you'll observe there is one more point here where something similar happens here also. If you look at this point here, let's call it B, YB is also 0. If you look at this point here, YB is also 0. If you look at this point here, this should be the peak here. YB is again 0. Now, what is the distance between them? Can you see the distance between them? Between these 2 points, the distance will be half of the wavelength. Is this making sense? That means for a distance of every lambda by 2, you will find a point which is not moving. Similarly, I can find one more point on the right-hand side. Is this clear? This is more of an intuitive thing. We are not doing anything mathematically. We are just saying two waves are passing through each other. What happens? So there are certain points where this red and the blue one will always cancel out. And there are certain points, which we will see next, that will be this point in the middle. You will see something else happens there. Any doubts on this page? This understanding is quite important. Huh? Stationary waves used to confuse me a lot. I used to think about all weird concepts about stationary waves. Clear? Now, if you take the other case, so this point we already saw, this was A, and we saw this point already here, this was B. Now, if you consider a point C in the middle, right, and if you consider a point D in the middle, again, clearly observe this, the red is pushing maximum, the blue is also pushing maximum. So here also the blue is pushing maximum, the red is pushing maximum. So at this instant, the displacement of C is 2A. The displacement of D is 2A. Next moment, after some time, when these waves are going off, you'll observe at this instant, if you clearly see again, now yc becomes 0 and yd becomes 0. They cancel out. I didn't draw it properly. So they're canceling out. And then if you continue, you'll observe they become like this. You will see again this yc will go to 2a, and this time yd will go that side 2a. And again, if you see the distance between them, again this is lambda by 2. I hope you're getting this thing. So here you can clearly see A and B are nodes. So these points will never move no matter what you do. Whereas C and D oscillate with an amplitude of 2A. When they'll go from minus 2A to plus 2A. Their amplitude has become double. And the distance between these consecutive 2 points is always lambda by 2. We can just see this thing from a diagram. Any doubts on this? Clear? Any confusion? So now when you do this whole thing together, and when you see a stationary wave on a string, this is what you will notice. So let me just put the whole thing together. So you'll observe point C, point so the distance between the two nodes, which points won't move, is lambda by 2. And you can see by symmetry here, the distance between these 2 points is lambda by 4, and this is another lambda by 4. So here A and B never move. Nodes, and distance between 2 consecutive nodes is lambda by 2. Without any max, nothing, we proved this. Clear? So now whenever you have to represent a stationary wave, we use this symbol. This is how we represent a stationary wave. Turn in the page. So we represent stationary wave with a symbol like this. Getting it? So what is this exactly? I used to think when you send a stationary wave, the string will break into 2 pieces and the 2 parts of the string will oscillate like this. And it never made sense. Like, after that, why did the string again join back? So these are different positions of the string. Let me show you what these are. These are different positions of the strings at different times. Meaning, This is the position of the string at T1. Next moment, the string will become something like this. This is T2. Next moment, the string will become flat. This is T3. The next moment, the string will come down. And this side will go up. This is T4. The next moment, the string will become like this. This is T5. Now the strings start going so fast, you start thinking it's like a loop. That is where the name comes. The string is a stationary wave or a standing wave.
Okay, this is a demonstration of...
Nah, not this guy.
So what
Yeah.
we have here is a frequency generator. It's connected to what's called a wave driver. It's just a speaker. It's going to pump up and down at whatever
Now here you can see this thing, right? When you switch it on,
frequency I set this guy to. When this sends a wave, it comes back. Now,
now see when he switches it on, can you see how it is moving up and down? Observe that again. When it goes up and down, that will start sending waves on the right hand side.
Yeah, let's go higher. So it's sending waves back and forth, but these waves are out of sync, if you like. They're not exhibiting consistently constructed.
Now first thing, see, for stationary waves, how many waves you need? 2. So how do we generate this thing? So he's using one wave from the source. That wave will go on the right side corner and then will get reflected. So we're using the reflected wave and the incident wave as 2 different waves. And now we can be sure they have same frequency, they have same amplitude because it is the same source. And assuming there is no dissipation, approximately we can say both are identical waves traveling in opposite directions, the reflected wave and the incident wave. Now when these 2 waves, meet at a certain frequency. Now why the frequency is important, we will discuss later on. When you tie the string, you did something, you restricted the situation. So, but let's say if things work out, see what will happen.
Interference at any one point.
You can see there is no wave, nothing, everything is messed up actually.
For example,
there.
I have what's called a standing wave.
So at a particular frequency, you can see that loop.
That's sent down and reflects constructively right at this point.
You can see the midpoint there, it's not moving. Did you see that point is just fixed? That is your node. And you can clearly see in slow motion, when I put a pause there, can you see it is a sine wave? And the distance between the node and node is lambda by 2. That is half of the wave. Now, if you see this in slow motion, you'll actually understand why you're getting like this.
That interfere with the incoming waves right here. And that's called a node.
See, if you catch that also, nothing happens. That's because it's a node, it doesn't move. Even if you're catching it, you're not going to affect the scenario here.
Working. So the node is not moving, it's moving up and down.
Let's see that in slow motion, you'll understand.
In a second with the high-speed camera.
That is how actually the string is going. Can you see how the string is going? This is what I was saying. They go right now, I paused it. At this time, the string is like this. This time, the string is like this. Can you see what is happening? Every time I pause, you saw the different position of the string. But because it is oscillating so fast, our eyes will think it is like a loop. That is where that symbol comes from, like a loop. And there are no two strings here, it is a single string. I used to think it broke into 2 pieces. Getting it, such dumb things don't happen here. So, and there, it goes there. And did you notice one more thing? All the particles on the left are going up. At the same time, all the particles on the right are coming down. The 2 loops are always out of phase by 180 degrees. If the left thing goes up, the right one comes down.
So here we have what's called the second harmonic. It's the
2 loops are called second harmonic.
For a standing wave for a string that's held at both ends. Because this is a node, and now the first one.
Now if you change the frequency, this is a single wave, first frequency, first harmonic.
And there we go.
1 loop. In slow motion, see, this is how it looks. The center point is an antinode. Slow motion, actually it is a single string going different positions. But when you see in a fast
This
motion,
is
it gives you a
scenario
feeling it's a loop.
Jump.
Persistence of vision, our eyes can't
I
figure it
can
out.
find any of the other all of the other harmonics are multiples of this number. So we just saw that 2 times this number was the second harmonic, or the second possibility. Well, if I go, well, 25.
If you go higher frequencies, you can see 3 loops.
And there we go.
This is your third harmonic.
So that's the third harmonic. How many wavelengths is this? Well, it's one
You can see 1.5 wavelength.
and a half. 1 1/2 wavelengths. And it's easier to see in high speed. So check out
Now,
this
see, if you
shot
see that in
with
slow
high
motion, you
speed
can clearly
camera
see something.
And verify for yourself that it is 1 1/2 wavelengths.
Can you see how it is going? Let me look at this thing. The left loop is going up, the center loop is coming down, right loop is going up again. If you see every consecutive loops, right, every alternate loops, they are in phase. This is what I was saying, and this is the positions of the string. When it goes so fast, it starts giving you a feeling you're looking at a loop. That is why the symbol looks like that. This is your third harmonic or 3 loops, and you can clearly see the nodes are not moving actually.
So again, third harmonic, 1 1/2 wavelengths. Well, let's double.
You can bump up the frequency, you can see 6 loops.
And there we go. That's the 6th harmonic. Beautiful. And it's 6 times the measured in the beginning. 1, 3, the exponents.
In slow motion, it looks amplitudes have become too small, but you can see. Clear with that? So there, stationary waves do exist. It is just not our imagination. And using stationary waves, you can do a lot of nonsense things. You can destroy bridges. Let's see how to destroy a bridge. Practical applications. This
As
is
you
a
can
Tacoma
see,
bridge.
this bridge was exceptionally
Pretty old video, 1940.
long and narrow. Wide.
We'll go to the main thing.
See the steel useful light.
So this was a bridge opened in 1940. 40 and 38, I guess. Now see.
The bridge suddenly went into a twisting motion. The wind speed was a steady 42 miles
This
per
is not
hour.
graphics, huh? That
This
is
was
a,
enough
you
to keep
can see the
bridge
stationary
oscillating
wave.
in one of its natural modes of vibration with a period of 5 seconds.
So there is some issue during that time, right? People didn't have a concept of, people never thought wind can affect bridges. This thing, what happened? It's a wired bridge, no? So whenever the wind was blowing at 40 to 50 kilometers per hour, the wires on the left side and right side, the grade ka wires, are acting like tuning forks. So they started vibrating and they're sending waves through the bridge. And for a particular frequency, it is called natural frequency. When that frequency matches with the external frequency, when external frequency matches with the natural frequency, right, you get stationary waves in the system. You must have noticed this, when you're going on a scooter or an vehicle, right, at a certain speed, na, the whole vehicle starts vibrating. Ever noticed it? When you're going on a vehicle and you're increasing the speed, at some speed, na, it goes like, starts rattling. If you increase the speed, the sound goes off. If you decrease the speed, the sound goes off. But at that particular speed, the whole vehicle is rattling. Not sure whether you ever experienced it. You need to take a little spoiled vehicle, old one, and then you will try this, you will feel that thing. But anyways, so we have a bridge here, there it is oscillating. That's a concrete bridge. मतलब ऐसा सोचो ना, the construction का quality इतना अच्छा है, bridge is not breaking.
Went out to see what had happened.
Our Bombay का bridges to break without anything.
Walking with some difficulty along the nodal line, which is the center stripe of the roadway.
There is a professor in the middle. He went to test it out and is coming walking. Can you see? Video इतना अच्छा high quality नहीं है. I'll post it in the group anyways. This is a side view. Look at that thing. Na? That thing had an amplitude of 2 meters, it seems.
It's remarkable that the girders were this flexible. This is photographed at normal speed. However, a collapse was inevitable after a little more than an hour of this.
1 hour it did this dance. saying, look at an amplitude. Right?
The car had been abandoned earlier. No one was injured in the whole affair. However, a small dog in the car was frightened and was afraid to come out, and he perished along with the bridge.
So there was a dog which was there in the car. It got scared and didn't come out. It died with the bridge. So when I said that in the class, people were like, oh, poor dog. I said, bloody, that dog died 80 years back. That's 1940 ka dog, that is. Right? People are showing sympathy for the dog now after how many years? I don't know. 80 years? So it's fine. Can't do anything about it. And there, bridge finally collapsed. The power of stationary waves. Now you know why you're learning stationary waves. There's a purpose. You can destroy bridges. You can destroy buildings. You can create something called a vibrational warhead, which can generate the natural frequency of the object. And if that goes and hits that particular object, it cracks. So, yep, that is there. But this thing is actually a big issue in construction. In 1975, in a dance floor in Kuala Lumpur or Bali, Indonesia, I don't remember, one of the city, the dance floor was in a second floor. And you know how it is. When people are dancing now, they sometimes, you know, like, let's say the music is coming like tuck, 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 tuck. So people dance with the theme. So the DJ was playing something and the people are jumping and the beat frequency became 2. Matlab, he was beating it 2 times per second. And so people were all jumping and coming down, jumping and coming down. Now, when all people jump together and come down, right, what happens? You're hitting the floor at the same time, you're generating a wave. Unfortunately, the wave natural frequency of the floor also became 2 beats. So this is what is actually happening in that thing. See, when you send a wave, think of like this. So let's say you send a wave, example, 100 energy, it goes, hits the thing, and let's say it loses energy 50% and comes back, and again hits here, and let's say again loses 50%, so 25 bacha. Assuming every time it loses 50%, 25 is left out. Now, at the same time, if these people jump again, now the time taken for this to go and come back is 2L by V. So if you can match this frequency, that means if these people jump again exactly at the same time, you are generating one more 100 ka wave. Now what is the wave energy? 125. So 125 will go and come back again. This time you'll be left out with again some more energy. Again you're hitting 100. You're getting what is happening? The energy just keeps on piling up, piling up, piling up, piling up. At one point you reach such a high energy level, this floor cannot withstand that kind of energy or the pressure or tension. The whole thing collapses. I think almost 80 people died in that accident. The entire dance floor collapsed from the second floor. 80 people died, and after the regulations came, the dance floor ka beat frequency should be 5. People can't jump 5 times per second. Right? So that was one. And school, we must have studied this. Remember, when soldiers are walking on the bridge, they're asked to break the steps. Did you ever study the statement? Same reason. Because when people are walking on a bridge, everyone has steps are random, so it doesn't produce a one unique wave. But when soldiers are hitting the bridge at the same time, left, right, there's a chance you can hit a natural frequency and the bridge may collapse. So that is the reason we say to break the steps. So the whole thing is a stationary waves ka thing only. So let's see how do we get the mathematical part of this. But is this clear, everyone? Getting it, I didn't use any max, any equations, nothing, simple principle of superposition. This is what I was teaching you last time, how to add 2 waves. There we did Batman and all, but here, sine waves. Now, let's go to the mathematical part. So the equation of stationary waves. So let's take the 2 waves. So y1 is a sine kx minus omega t. We should take 2 waves of same amplitude, same frequency, but traveling in the opposite direction, kx plus omega t. Now, when you add these two, the y resultant is y1 plus y2. Then this is 2a sine kx. I'm writing it directly. You know, right? Sine a plus sine b. So sine a plus b by 2 cos a minus b by 2. So that thing comes out to be cos omega t. Now, let's try to understand this equation. This each one means something. This first part here, if you just forget about this part, doesn't this look like SHM? Forget about the first part. This thing looks like an SHM. So what you're studying actually here is the 2A sine kx is the amplitude of a particle at x coordinate. That means for different x values, you have different amplitudes. And this cos omega t here represents SHM of that particle at x. So a wave is simply nothing but, n number of particles oscillating in SHMs with different phases. That is the simplest way you can think of. There are 100 people, they are doing 100 SHMs, all are not together. So that up and down motion is what we end of the day get as a wave. So if I try to draw this is how it looks. So that bump or that hump thing which we drawed before. So if you take this is x is equal to 0, right? And this is some x is equal to L. So at a particular distance x, this would be the amplitude of this particle, 2a sine kx. Meaning this particle at x coordinate cannot go more than 2 sine kx upwards and downwards. So if you take the whole thing, you can clearly see here, these things have 0 amplitude. These are nodes. Basically, this is x is equal to 0 and this is x is equal to lambda by 2. So this thing will have some amplitude, this thing will have some amplitude, this thing will have some amplitude, this thing will have the maximum amplitude. This is 2a, which is the antinode. Again, the amplitude decreases. This is what happens to the motion. So different particles have different amplitudes. So in a progressive wave, so listen to this thing. In a progressive wave, we have, let's say, 100 particles all oscillating with same SHM and same amplitude, a sine omega t. But when we came to stationary wave, we have 100 particles, 100 of them are oscillating with same frequency, but different amplitudes. Are you getting the difference between a progressive wave and a stationary wave? So when you have a single wave, all are going like with same amplitude to the same position. But here, everyone has a different amplitudes. So different points have different amplitudes. Have a look at this page. Now this here, which we have written, for now we will use this, but this is not the general wave equation for a standing wave. There is even a better form of writing it, but for now, let's use this as a standing wave for our sake. This thing works. Most of the time, this thing works. But there is a more general way of writing. We took a very special case. Clear? Next thing. Next thing. Turning the page. So what we proved, with a picture, let's try to prove it mathematically. So we got the amplitude is 2a sine kx. So for nodes, so I want to look at the nodes on the string. Amplitude is 0. Don't get confused. What is A here? A is the amplitude of the single wave. The two waves which we generated, uska amplitude A tha. So that means sine kx is equal to 0. That means kx is equal to n pi. And k ka value I know 2 pi by lambda into x is equal to n pi. So x is equal to n lambda by 2. This is what I was saying. So nodes are correct. Lambda by 2 ka distance. The nodes are correct. X is equal to 0, lambda by 2, lambda, 3 lambda by 2, and so on. This is a mathematical proof, like why you get nodes at every lambda by 2. But this is not intuitive. Mathematically, I'll show you. You will feel like, it is right. Just have a look at this. Just give me a minute. Someone is ringing the bell. No one is there in the house. Next time. Now, the same thing. If you want to find the antinodes, what to do? The amplitude should be 2a. So we get sine kx is equal to 1. Then we know kx is equal to n pi plus minus 1 whole power n pi by 2. And this thing turns out to be, if you keep substituting the values, 2n plus 1 lambda by 4. So we get x is equal to lambda by 4, 3 lambda by 4, exactly between the nodes. These are antinodes. Clear? So there we figured out the positions of the nodes and the antinodes mathematically. But this thing we already proved it before on the picture. Any doubt so far? Going ahead. Now, if you take an infinite string and if you try to send two waves, you will always get a stationary wave. If you take on an infinite string without any fixed points, any frequency would generate stationary waves. That is because for different frequencies, we have different wavelengths. So the distance between the nodes will be different for different frequencies. Any frequency would generate stationary waves. Let's say if you take a frequency 100, it has a particular distance. If you take 200, particular distance. So there is no problem as such. But on a string fixed to a point, now you're creating a physical constraint. The fixed point has to be a node. Example, let's say we take a string like this and you fix it up here. You can. And let's say this thing is also fixed with a source or something. We have an oscillator here. Now see, the problem is what? This point has to be a node. This point has to be a node. So for example, let's say, and this length is 1 meter. And let's say we have lambda is equal to 3 meters. Now for lambda is equal to 3 meters, what should be the distance between the nodes? Lambda by 2, which should be 1.5 meters. Or let's take even smaller. Let's say lambda is 1 meter. Then distance between the nodes should be lambda by 2, which is half meter. That will actually work out, I guess. Let's take 2.4 meters, let's say. That's 1.2 meter. This is better. 0.9 meter. Now see the problem with this. So this is saying this is a node, fair enough. Distance from here, 0.9 pe, we need a node here, isn't it? According to the equation. You're getting it? According to the lambda, it says I want a node here at 0.9 meters. But the problem, you created a node at 1 meter because of the physical constraint. You tied the string there. You're not letting it move only. So the equation and the physical system both are not working together. So this point will try to remain at rest, but because this point will try to be pushed up and down, but you're not letting it move. So you will not get any stationary, isn't it? The whole pattern will get messed up. Are you getting the point here? So we need a node here according to the lambda, and this point here, and x is equal to 1 meter should move based on the equation, but it cannot move. But since it is fixed, it cannot move. So you can't get a stationary wave like you think. Basically, you're creating a constraint here. The equation and the physical system are not in sync. Are you getting this? So you will not get stationary wave for any frequency. So for a fixed string, so we get stationary waves only for certain frequencies. We get stationary waves when the physical system, when I say physical system, whether you're tying the point, leaving the point like that, and the equations are in sync. The equation should say this is a node. The physical system should accept like, this is a node. Because this point is, we are keeping with the tension array. This point will always touch the pulley. If you want to open end, or else, just imagine this string will keep flying like this. It's like a fixed end, right? The wave will come here, hit and go back. You will not get a wave going like this, right, to the block. Equation should be in sync. Is this clear, everyone? So from here comes our thing, sonometer. So the experiment, right, or the lab mein when you go and see, this is the device which we use to produce stationary waves and study. Let's see, what is this? Sonometer. Not sure whether you've seen this in your lab. This thing looks like, this setup looks like this. Seen anything like this in the lab?
Yeah, we did the practical this week only.
So sonometer thing. So to put it in simple words, right? Let me show in a more simpler form. The simpler form would look like this. We have a fixed end here. We'll keep a block M here. Okay, and this point is x is equal to 0. This point is x is equal to L, and we use a tuning fork to generate frequencies. So basically, this is a mass. So you can is an adjustable masses. So by changing the mass, you can change the tension. So by changing the tension, you can change the wave speed. You're getting? We want to study different properties, right? So here tension would be mg, and v wave will be root over t by mu. So by changing mass, you can have different wave speed. These two things are there. These two things, right, are called, these are the wedges that can be moved. Basically, you can create different lengths. Who will go and bring a new string every time, right? if you actually see a sonometer, na proper table ka setup, it just won't have one string. It will have something like 5 or 6 different strings, so that each string ka mu is different: thin string, thick string, and so on. But in general, this is the basic setup. So we can change tension here, we can change length here. Is the diagram clear? So the simpler version of the diagram is this is what we use. But this is a sonometer. So sometimes in the exam they'll say like this thing, in a sonometer, this happens. So don't get confused. Let's say now look at the different possibilities. Remember, just now I said there is a restriction. You cannot generate any frequency and expect a stationary wave. So the first possibility, if you understood this thing in sound waves, the stationary wave is exact same idea, but there we'll talk about sound. Everything will look similar. And this idea is important. I'm putting it in very, very simpler terms. All max and all is fine, but really when you understand why you're getting stationary, what you're getting, even if they mess up something with the question, you can handle it on your own. So here, first possibility, x is equal to 0 and L must be nodes, physical constraint. You tied them, there's no option there. And the left side, that thing is lying on the top of a pulley. You can't have the string flying over the pulley there. So the first possibility is you get a single loop. X is equal to 0, x is equal to L by 2. Distance between the two nodes is lambda by 2, which we proved. Therefore, lambda by 2 must be equal to the length of the string. So from that, wavelength should be equal to 2L. Therefore, frequency is equal to V wave by lambda, which comes out to be V by 2L. This is called as the fundamental frequency or the first harmonic. So fundamental frequency is the minimum frequency which gives you the stationary wave.
So, but like you can generate a wave which can like like make
You
that
can
point
generate
on the
a
pulley.
wave, but वो stationary नहीं होगा.
Oh, acha.
You can generate a wave. Things will go a little, they'll all become mixed up.
So it's possible to make that mask like go up or something.
You do. Then the whole thing goes off, na. Then this thing will start acting like an antinode kind of thing. But it's
Okay.
not a proper antinode also because you're not letting it go freely.
Yeah, understood.
So we make sure not to make that fly. But if you give enough energy, even that will start flying. We'll not get into that. We're assuming that is just sticking to the thing. Because kya hoga na, if this thing starts moving, indirectly you're saying the block is also going up and down. The tension
Yeah.
is not constant.
Got it. Yeah.
Tension won't be mg. That creates a problem. Kya ho gaya, Ishan? You become so happy suddenly because block is flying.
No.
Because you're doing some interesting dance, so I thought, okay. This
I just
is
thought
also
it.
called as, you thought of something.
Yes.
This is the first harmonic. इस बार IIT Bombay civil का girls के लिए rank improved by almost 600 to 700 ranks. The girl who got 8,300, 400, she got into IIT Bombay civil. Boys, so 4,400 people, most of them took chemical. One guy took an IIT Roorkee chemical, one guy took IIT Gauhati chemical. 4,400 and 4,700. 2,000 people mostly took an IIT Madras mechanical. The 795 guy took IIT Bombay electrical. So there it is. And this Parag, he got IIIT Hyderabad also, computer science. There was an interview and everything for that, but okay. कल तक तो वही चल रहा था उनका. So anyway, this is the first harmonic. Nah, seriously, first time I felt like, teaching JEE was easy. Counseling was more harder. And some people to brought so many weird colleges and I don't even know they existed. Finally, I had to hire a counselor. Second possibility.
Hired a counselor for the first time.
हाँ,
Oh,
They're asking me any nonsense, तो मुझे answers नहीं पता. So what to do? I can't say anything. So I hired a counselor for 1 hour session. He came and said, and then I said, किसको भी personal counseling चाहिए तो you can hire him. People had weird questions, right? Kharagpur में Jain food मिलेगा, right? Huh? Can we go to Madras? वहीं पे कैसा होगा? Madras में do people talk English? If we speak in Hindi, will they beat us? अबे यार, अभी ये सब, अभी what will I answer all these things? तो फिर भी college के बारे में, if you ask me how is the course and all, I'll be able to tell you something. And courses also, what happened ना? Lot changed. Last 2 years में, 2 years छोड़ दो. This year only they changed a lot. Kharagpur removed all dual degree programs. They made everything BTech. There's no dual degree program in Kharagpur now. Madras introduced something called new AI. So there's a lot of new things came up in this year and last year. And I was unaware of most of these things. Like, who will keep track of all these things? And Jain food kahan pe milega? That is something I know all that stuff. So I said, people who wanted to ask all these weird questions, hire a counselor, talk to him, ask him, harass him, leave this innocent physics teacher alone. So something like that. Next thing, go ahead. Second possibility. Now, what is the second possibility? We get 2 loops. Now see, understand one thing. The only condition you created is the right side x is equal to L must be a node. The left side x is equal to 0 is equal to node. Bus. This is the only condition. I never said you cannot have nodes in the middle, isn't it? The physical condition is the 2 edges should be nodes. And this center will be x is equal to L by 2. So this guy would be lambda by 2. So now we have lambda by 2 is equal to L by 2. So lambda is equal to L. So we get frequency. Let's call this thing F2 is V by L multiply and divide by 2. This is 2V by 12. This is called as second harmonic. Now, and this is also called as first overtone. So what are these harmonics? Harmonics are multiples of fundamental frequency. So here the fundamental frequency is V by 12. Uska 1 time is first harmonic, 2 times is second harmonic, 3 times third harmonic, and so on. And overtones are simply the frequency after the first harmonic. The first frequency you hear over the tone, basically after the first fundamental frequency, whatever you hear, that is a fundamental frequency. Frequency after fundamental frequency. Now, there is no guarantee har baar first overtone, second harmonic hoga. We will see later on it is not true. In this case, it is frequency after fundamental frequency. Now I can go ahead and give you the third possibility also. I'll just write it down here. I think by now you got the hang of like why you can get different multiple number of loops on the same string. Because the only condition you said, the edges should be nodes. You never told me anything about the center. So we can do anything. So this is x is equal to 0. This would be x is equal to L by 3. This is lambda by 2. Same story. So if you actually understand this thing, when a question comes, even if you don't remember anything, you can use this concept and solve it on your own. So we end up with F3 is equal to 3V by 12. This is your third harmonic, because third time, and second overtone, second frequency after the fundamental. And so on. I can keep playing like this thing. So next one, next one, next one, and so on. So now combining all this, we can put a general equation. Let me show it in the next page. So Fn will be n times V by 12 And we know the wave speed is nothing but root over T by mu. There, this is your equation. The nth harmonic is n by 2L root over T by mu, where Fn is the frequency for the nth harmonic. You can also say this is n loops, at least in this case. L is the length of the string. So that n is the harmonica number. If you say 1, n is equal to 2 loops, 3 loops, so first harmonic, second harmonic, and so on. T is the tension in the string. Mu is the mass per unit length, linear density. And that V is actually the wave speed. This is your formula for frequency. Have a look at this. And the best thing about this, you have seen this before. You have seen this multiple times. Maybe you just don't realize it. Let me show you where you have seen this. All clear with this? Where did you see this thing? A guitar. Every stringed instrument that you know of is a sonometer. So if you look at the guitar there, what you're doing, guitar, violin, basically any stringed instrument. So think about, I'm sure some of you know how to play the instrument. Now, if you look at the equation here, the frequency is n by 2L root over T by mu. This is what you're doing. Ever heard this word? I'm tuning the guitar, I'm tuning the instrument. By turning this thing, by increase or decrease the tension. You can tighten them or you can loosen them. Getting it? So by tightening, we can change the tension. So you are changing the tension in that equation. Getting it? And if you look at here, look at the strings here. This is thick. This is thin. Basically, mu is changing. So we have different strings with different mu's. So by plucking the strings, different strings, you are creating actually different mu's there. So different frequencies will come. So if you pluck the strings at the same point, all of them will not produce the same frequency. Different thicknesses have different mu's. See, all of them will have same rho, volume density will be same, but mu will be different. But different mu's. And by putting your fingers at different places, we can get different lengths. So if you're plucking here, you're taking this length. If you're plucking here, you're taking this length. So you're changing the length by plucking at different positions. So next time when you're playing an instrument and when you're learning an instrument, this helps a lot. Like, the teacher will say, put here and do like this, you will get something. Like, if you put here and you play, you'll get like sa, 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 whenever you pluck it. And then you pluck it here, you'll get re, re, re. I don't know, guitar, I think it doesn't happen that way. I learned violin. The violin does come. And I was very bad at the violin, don't worry about it. I learned 3 times. First time when I was in IIT, I learned for 2 years. Then I told your teacher, kicked me out. It used to be weekly 1 class. We asked to go do the homework and go. We never did. And then I learned when I was in Hyderabad, but I learned for 2 weeks and it's gone. Then I learned one time in Mumbai. This time I learned it very seriously for 2 months. I learned how to play Till Twinkle Twinkle Little Star. And then, yeah, but it was a horrible experience. So when I used to play that, violin in my room, I used to close the doors and practice. I used to get a feeling like violin is crying. Please leave me, don't play me. Like, why are you harassing me? What did I do to you? It seriously used to feel like it is talking to me. Like, why are you torturing me? What did I do to you? Like in the past life. So for a moment, I thought maybe violin is not tuned properly. Maybe violin is not fine. But I know something was wrong with me. Then I took it to the teacher who was teaching me and I showed it to him. I said, sir, I think maybe there's some issue with the violin. He said he took it. He started playing. Arey, yaar, he played so beautifully. Yeah? Matlab, for the first time, I felt like how hopeless I am. I said, like, it is not the violin ka fault. It is me who don't know how to play it. That same violin was like now playing and it feels like it's calling someone. But when I played, it feels like it's crying and running away. But with more focus, I started practicing more every day, half an hour. I think my roommates were suffering, but can't do anything. I learned till Twinkle Twinkle Little Star. It did actually sound like Twinkle Twinkle Little Star. I was proud of myself, and then I became busy with work, and then I forgot again. There is a plan next year. Let's see. Now I'm placing hand. So when I was learning violin, think na abhi wahi hoga. Physics teacher ka head na. I was thinking, why should I pluck here? Why should I put my hand and do here? That is when I figured out, yeah, this is a sonometer. So I was not learning violin there. I was thinking about sonometer there, but can't do anything. So we're placing hand at. Kya ho gaya, Ishan? You don't want to come to the party, kya? You want to run away at the party?
So are you going to play the violin at the party?
Please play.
Please, सब लोग हंस के जाएंगे.
So are
अभी
you
कुछ
going
भी
to
याद
dance?
नहीं है रे. Dance also. इतना कुछ नहीं है रे. It is just a very cool thing. I'm a very shy type of person. I don't do that, but ठीक है. Last time someone forced me like that, so I literally did all physics का dance कर लिया. Meaning SHM motion. I started putting my hands like this. I said SHM. Then I did rotational motion. And then I did lots of motion. सब physics पूरा कर लिया था. And it is like, meaning if I didn't shout those words, it would have actually looked like dance, I guess. You should try something like that. Meaning simple, na, see. You can even play the dance with max. Y is equal to X. Y is equal to minus X. Y is equal to sin X. Y is equal to tan X. There, so you can see a lot of, I think automatically steps are, you can just play the sin X cos X, the dance bani jayega. Who knows, the other person who's seeing will think like, here to kuch naya steps hai. How does he know? We are just playing mathematical equations there. Anyway, so there we can, so sonometer, right? We're putting at different points, you get this thing. So what is this harmonics here? We have something called octaves. Again, people who played instrument, you will know, but even without that, you will understand. The octaves are, this thing normally, the sa, re, ma, pa, ta. I need more space. Ni. And if you see, again, you get a sa. You can see the sa repeats again. So if you just keep on increasing the frequency, right, this is your first harmonic sa. For example, let's say, this is 100 hertz. That is not 100, it's something else. Let's say this thing is something like 125, right? 110 or something. And let's say this is 200 hertz. Again, you get a sa. This is the second harmonic sa. Meaning the first one will be like sa, second will be more sharp sa. You're getting it, the frequency becomes more sharp, but still you'll hear the sound sa. And if I go more, you'll get one more sa, 300 hertz pe. This is your third harmonic sa. So these are the harmonics. You're getting it? So octaves are simply that set of frequencies which will keep repeating at different frequencies. So that is actually your N. So you can see this thing literally, the tension, mu, length, N, you can change everything. That's the reason, right? The guitar can produce like literally every kind of frequency that you can think of. So any stringed instrument is a sonometer. Guitar, violin, sitar, this thing, piano is again a stringed instrument. If you have seen Tom and Jerry, right? In that there is a scene. Jerry is running inside the piano. This guy is hitting the keys and the hammers are hitting the strings. That is how I came to know actually piano is a stringed instrument by watching Tom and Jerry. So, anyways, so clear with this? Let's see some questions. What was the last question? 14. So there, we just know one equation so far. We are going to play with this, and then and we also know the equation here: 2a sine kx cos omega t. So they are the two things that we know. Let's start with an easy one. We have a string x is equal to L. We have a block here. This is rho B. This is rho L. So initially the string oscillates. In second overtone before immersing. And then it oscillates in third overtone when immersed in the liquid. So you just need to see in that equation what is getting messed up and accordingly solve. Find rho block by rho liquid. Get it? Easy one. So in the equation, F is equal to N by TL, T by mu. Now see, it is the same tuning fork. We are not changing the tuning fork. So in both the cases, we are using the same source. So we are not messing up frequency. We are not messing up length. We are not messing up mu. So what we are messing up is N and T. Bas, that is how what you have to figure out and finish it off. Get it? Fluid mechanics and waves. Oh yeah, 5 by 9, 9 by 5. Okay. So initially tension T1 would be mg, which is rho bvg. Tension T2 bind force is rho lvg. Mg is rho bvg, so T2 will be. So we can see frequency is n by L root over T by mu. So n into root T is constant. Be careful, these are overtones, harmonics नहीं है. Second overtoning मतलब third harmonic, third overtone मतलब fourth harmonic. Be careful. ये trap था. That's a overtone, harmonic नहीं है. So this is your harmonic. So second overtone is 3. Tension will be root over rho B Vg. This will be 4, which will be rho B minus rho L Vg. Plus हो गया था. Cancel this. Put a square on both sides. 9 rho B is equal to 16 rho B minus 16 rho L. 16 rho L is equal to 7 rho B. Rho B by rho L is 16 by 7. Yeah. 16 by 7. Ishan, you got it. Looks like everyone else fell into the trap, yeah? Check. Be careful with that overtone. All clear? Easy? Next one. Question is the direct substitution. You know the formula, put it there and you're done. Just be careful with the words. 16. Let's say the equation y is 10 sine pi by 3x cos pi by 60. Here x and y are in centimeters. For people who forgot, I'll just write the general equation. General equation is y is equal to 2a sine kx cos omega t. This is the thing which we are using. But like I said, there are other forms also. You'll see later on. For now, let's use this. So the first question, find speed and acceleration of the particle at x is equal to 2 centimeter at t is equal to 2 seconds. So specifically one particle on the string ka speed and acceleration. Find v wave. Find max speed and max acceleration of a particle on the string. This is a stationary wave on a string. Like I said in the beginning only, when we study transverse wave, we study waves on a string. So there should be no confusion about that we're using something else. I will mention if it is some other weird wave. So if length of the string is 30 centimeters, find the harmonics, meaning how many loops are you forming? Find phase difference between x is equal to 2 and x is equal to 2.5 centimeters. That is one part of the question. X is equal to 2 and x is equal to 3.5 centimeters. Phase difference. Remember last class I was telling you, on a progressive wave, different points have different phase. Let's get them all. In this, the E is the question which I'm more interested in. Remaining all fine, you'll get it. Any doubt so far? Ali, clear so far? Ali, are you there? Ali, are you there? If you don't respond, then you can give you any pani puri. Okay. You responded. Maulika, Neil, clear with this so far? I hope the stationary wave ka, what is stationary wave, why it is coming, equation, I hope things are clear now. Arjun? Wave so far is
Yes,
fine. You said you're
What's that?
having issues before, na? Wave so far is fine.
Yeah, it's
You said you're
better.
having issues there at the classes, right?
Yeah, I started the module also.
So that's it. First one answers. क्या करना था? How do you find speed from a wave equation? dy by dt. Why do you think need so much? Differentiate. Y is the position. Differentiate dou by dou t. Partial differentiation. Differentiate 2 times, you'll get acceleration. Isn't it? But straightforward. There's nothing more to do there. So y is equal to 10 sine pi x by 3 cos pi by 60. Since this function is depending on two variables, velocity will be dou y by dt, meaning x is a constant, only that thing cos is a variable there. Sine pi x by 3, and this thing is minus pi by 6 sine pi by 60. So minus 5 pi by 3 sine pi x by 3 sine pi by 60. Acceleration, double differentiation. Differentiate this guy again. One more 6 will come out. Minus 5 pi square by 18 sine pi x by 3. That guy will become again cos pi by 60. Clear? So just substitute the value of x is equal to 2, t is equal to 2, you'll get the answers. That's it. So in this functions, put x is equal to 2, y is t is equal to 2. So I gave you velocity and acceleration at a given x at a random x and random time. So this is more general. What is v wave? Omega by k. That is still valid. Nothing changes there. Here omega is pi by 6 and k is pi by 3. Half meter per second. Half centimeter per second. From here you can clearly see Vp max would be, remember formula from SHM? Amplitude into omega, but यहाँ पे amplitude होगा 2a sine kx into omega. This is the maximum speed of any particle at a position x. Among the particles, the nodes have the maximum speed. So every particle has its own maximum speed. Among those maximums, the maximum guy is the antinode. So for antinodes, the maximum speed, this is the maximum speed of any of the particle, is 2a omega. Similarly, acceleration of the particle, like you can use everything in SHM. A omega square is the acceleration. So 2a sine kx omega square. Again, for antinodes, A max is amplitude into omega square. I hope the first 3 questions are clear. Straightforward. Tha. Any doubts? Main thing is that you want velocity acceleration differentiate. There's nothing there. Check it out. Let's get D and D. D is also easy. Try. I'll give you a minute. Any doubts on 1, 2, 3? But if you just say find the maximum speed on the string, then I will assume it is an antinode. But if you want specifically maximum speed of any one particle, then you have to give me the position. Tenth hits. What do you mean by that?
I won't.
10th harmonic. 10 harmonics आ गया क्या? That I felt is too big, right? Let's see. Lambda कितना होगा?
16 is fine.
Lambda is 2 pi by k. Maybe 2 pi by 3. Yeah, that is 6 centimeters. So lambda by 2 is 3 centimeters. Yeah, 30 centimeters. So there are 10 loops. Yep, 10th harmonic. For length is equal to 30 centimeters, we can get 10 loops. The lambda by 2, this is the length of one loop. That is one harmonic. Nth harmonic. Clear? Right, Ishan. What about E? E is an interesting one.
Yes, and equal pi.
Yeah, you're right. Let me help you with the E part. Listen carefully. Yeah? First thing, phase angle is equal to 2 pi by lambda into delta x. This is wrong. This is valid for progressive wave. Progressive wave is a single wave. Stationary waves, there are two waves. So be careful. Stationary when we want phase difference, don't use this formula. Getting at stationary waves is a combination of two progressive waves. So this whole thing is gone. So how do you do this thing? If you remember, when I gave this is what I was saying. If this string is up, all the points on the string are going down. Then these points on the string are going up. So within a loop, all the particles are going up together. Means all of these particles will reach their maximums at the same time. Now see, again, understand, when you say in phase, it doesn't mean we should go to same maximum value. When you go to maximum, I go to my maximum. When you go to minimum, I go to my minimum. Our maximas can be different. At the same time, these guys are going down. These guys are going up. So we can clearly see here, all points within a loop and alternate loops will move together. That is the phase is 0. Consecutive loops, points in consecutive loops move opposite to each other. The phase shift is pi, 180 degrees. Now from our data here, this point is x is equal to 0. This point is x is equal to 3. You're asking between 2 and 2.5 and 3.5. So x is equal to 2 will be somewhere here. X is equal to 2.5 will be somewhere here and 3 point will be somewhere here. So the phase between x is equal to 2 and x is equal to 2.5 is 0. Both are in phase. So stationary waves mein there's only two answers, either 0 or pi. Whereas in a progressive wave, you can get anything from 0 to 2 pi. So phi between x is equal to 2 and x is equal to 3.5. You change the loop now. You're in the other loop. Is pi. So if they ask you find the phase difference in a stationary wave, you need to figure out whether the points are in the same loop or alternate loops or consecutive loops. Don't use that formula 2 pi by lambda delta x. That's a blunder. And that option will be there. Because that we derived for a single wave. Here it's a combination of two waves. So the whole thing got messed up.
So in progressive waves, the same particle's amplitude keeps changing, right?
Huh.
Okay, yeah, got it.
So it's like this, right? Amplitude nahi bolna chahiye, Arjun. It is like, what is meaning amplitude? The maximum displacement you do.
Right.
Displacement. All got this? Take a break. Come back by 7-6. 7-7. It's zero cause that, yeah, they're going in the same direction. They're going up together and coming down together. So they're in phase. For amplitudency, won't we split it into 5 sine? क्यों split करना है? See, after Anika, after combination of both the waves, आपको जो आया था वही है ना? This is the resultant of both. So this starting part will represent the amplitude, na? Getting it? After combining, what you're saying is true, but उन दोनों को combine करने के बाद ही ये आया था. Clear? Sin A plus B and sin A minus B. हाँ आदित्य.
Sir, is the formula velocity of particle equal to negative of slope into wave velocity is still applicable?
That is वो तो प्रोग्रेसिव वेव के लिए डेराइव किया ना.
Okay, so it's not valid.
हाँ वो तो वैलिड नहीं होगा. वेलोसिटी ऑफ पार्टिकल अगर चाहिए तो नहीं लग रहा है ना, वैलिड नहीं हो रहा है आई गेस.
हाँ, नहीं हो रहा है.
नहीं हो रहा है बिकॉज वो सिंगल वेव के लिए डेराइव किया था. यहाँ पे दो वेव्स आ गए तो इक्वेशन ही मैसअप हो गया. मीनिंग ऐसा सोचो ना, दैट थिंग वी डिराइव्ड फॉर अ वेरी स्पेसिफिक केस. एफ ऑफ एक्स प्लस और माइनस सीबीटी के लिए डिराइव किया था हमने. Isn't it?
Yes,
This
sir.
thing doesn't have that form only, no, anymore.
Definitely.
So it won't be working out. Yeah. That was a good point actually. सोचा नहीं. चलो, take a break. Come back in 10 minutes. Yeah.
Sure.
Next thing. So let's see, based on the same thing, let me ask you a question. So if you have y is equal to 10 sine pi by 6 minus pi by 3t, ten sine pi by 6x cos pi by 3t, find the phase difference. Again, whenever I ask you phase difference, now think of like this. Let's say one particle is at the mean and going up, uska phase 0 hai. Let's say second particle is at a by 2 and going up, the phase difference is pi by 6. So the difference is pi by 6, something like that. So find phase difference between x is equal to 3 centimeter and x is equal to 7 centimeter. Remember, this is a progressive wave. This is a stationary wave. Stationary wave is nothing but a combination of two progressive waves going in the opposite direction. So the formulas won't be valid. Let's get this. Others do switch on your cams. Let's give it a try. Solve. 0. Okay. For the first one, I can use phase angle is equal to 2 pi by lambda delta x. That is basically k delta x. So pi by 6 delta x is 7 minus 3 is 4. 2 pi by 3. For the second guy, k is pi by 6 is 2 pi by lambda. Lambda is 12 centimeter. That means if you take your loop, each loop is 6 centimeter. So this is x is equal to 0, this is x is equal to 6, and this is x is equal to 12. So your 3 is somewhere here, 7 is somewhere here. Obviously, this will be going up and that will be coming down. So phase is pi. Simple, da? That's it. So you just have to be careful. Is it a stationary wave? Is it a progressive wave? Progressive wave, use progressive wave ka formula. Stationary wave, use stationary wave ka stuff. Stationary wave, there's no way out. You literally have to check whether they're in a loop or not. Clear? Next one. Turn in the page. A string of length 120 centimeters. Oscillates in 4th harmonic. Max amplitude is 4 mm. Find the minimum distance between the points with amplitude 2 mm. So maximum amplitude 4 mm matlab this is an antinode. So there are points with an amplitude half of this. So what is the minimum distance between them? This is the first question. Second question, same thing. If distance between any two consecutive points with amplitude √2 millimeters is 15 centimeter, then find the maximum amplitude. Reverse, huh? In the first case, I gave you the maximum amplitude. I'm asking positions for 2 mm. Second case, I'm giving you distance between 2 points, 15 centimeters √2 mm. Find the antinodes and find this thing. Let's get the first part. One at a time we'll do. Two different questions. Hmm. 10 centimeter. Okay. Yeah, maybe that is right, I guess. Let's see.
Sir, for the B wala question, what all is given?
Same
Length
data,
is
length is
given,
given.
harmonic is given, na?
Length is given. Harmonic nahi diya.
Harmonic nahi diya?
I'm asking, you know, find the harmonic also.
Oh, अच्छा, okay, okay. I can read.
नहीं तो एक काम करूँ क्या? I'll just put it as two different questions only. What should I say? With harmonic, with stationary waves, लिख लेते हैं बस. Length is given, but this time harmonic is not given for the second part. So let me write it as B. Ten centimeters, I think, yeah, three people got 10, so maybe right. Let's see. Now, in this question, now, there is one catch you have to be careful. When you get the loop here, now see, this point is 4 mm. Now this point is 2 mm. This point is 2 mm. This is where most people will think this is the answer, but you're forgetting there's also a point here with 2 mm. No? I never said the point should be in the same loop. I simply said the minimum distance between 2 points with an amplitude 2 mm. That means the answer could have been this or this, whichever is the smaller, that is the answer. So we need to check. So we know the amplitude is 2a sine kx. So here 2a is 4 mm, the maximum. So this is 2 mm is 4 mm sine kx. So basically kx is equal to, I'll just keep it simple, pi by 6. So this would be how much? 2 pi by lambda 1 by 12 centimeters. Lambda by 12. Fine. Now, from here, if you measure this, so lambda by 12, what is lambda here? You said it is a fourth harmonic. So length is 120 centimeters. So if you have 4 loops, so this should be equal to 4 times lambda by 2 is 120. So lambda is 60 centimeters. So lambda by 12 is 5 centimeters. So from here we can get this information. So this length was 5 centimeter. This length was 5 centimeter. This length was 5 centimeter. Basically, this is the distance from the node. By symmetry, it will be the same thing. And pura, this length is lambda by 2. How much is this? That entire lambda by 2 is 30 centimeters. Meaning this distance is 20 centimeters. Are you able to see? So if you take the 2 points within the same loop, the distance is 20. But if you take the 2 points on the alternate loop, the distance is 10. So what is the minimum distance? 10 centimeters. The points are on the consecutive loops. Because the question never said, give me the distance between the 2 points in the loop. The question was always find the minimum distance between the 2 points. So that x is equal to 5 centimeters is simply the distance from the origin or the left hand side. By symmetry, if this is 5, this also has to be 5. The total is lambda by 2, which is 30 centimeters. If this is 5, the balance is 20 in the middle. Any doubts on this? It's a good one. Most people get trapped there and they put 20 as an answer. Any doubts on this? Please ask. Let's get this. Second part. Something similar. The hint in the question is this. The distance between any two consecutive points is root 2 mm. Matlab, this case which is there, right? Meaning you take this point or this point or this point and this point, the distance is same. Isn't it? Because if the distance was changing, I would have told you, right? It is a different karke. But the statement is between any two consecutive points is root 2. Means if you take the 2 points in the same loop or in the other loop, it is the same. This happens for a very specific case.
Antinode 1.
Antinode hoga?
Uh-huh.
Let's say this is not antinode.
Oh, okay.
Antinode to easy ho jayega question. Let's say it is not antinode. There is another possibility. That would have been an answer.
Yes, I kind of got it. That's all.
Aryan, you're saying something. Distance between any 2 points is 15. Between any two consecutive points. Root 2 mm, रे. The amplitude is root 2 mm for any 2 points. उन दोनों का बीच का distance 15. Got it? Yeah. Fourth harmonic. Fourth आया क्या? वापस fourth आया. Okay. Maybe. 2 mm क्या? Okay. Let's see. Others try. In the paper which you guys wrote, na, there is a partial marking. nahi diya. I will do that. Don't worry about it. I'll get it done tomorrow. I think the operator forgot, I guess. I need to check.
But there's no guarantee that there will be partial marking in JEE, right?
कुछ गारंटी जेई का कुछ गारंटी नहीं होता है. JEE advance and guarantee are two opposite words. They feel proud about the fact, that there is no guarantee anything. They will put a paper so bad and they'll mess it up and कुछ नहीं कर पाएंगे. These are the same people, I think 16 or 15. They gave +4 -2. क्या guarantee है? People got slaughtered, but ranks got, meaning people who really worked hard, they got very good ranks. When paper becomes hard, it becomes very good for a person who has done the preparation well. Because your score will come less. Instead of scoring 90, you'll score 60. But the other guy who was supposed to score 60, he will get slaughtered and he'll get 10. Survival of the fittest. Welcome to the life. So I think, we have one answer. Let's see. The best thing about the question is that so you're saying there is a point here, root 2 mm. This point is root 2. This point is also root 2. And you're telling this distance is 15 centimeter and this distance is also 15 centimeter. That means this distance is 15 by 2, 7.5 centimeter. So this distance is 7.5 centimeter. So indirectly from here you got lambda. So lambda by 2 is 30 centimeter. We're getting the same thing. So 60 lambda by 2 is 30 centimeter. Length is 120 centimeter. Therefore, we get 4 loops. And is fourth harmonic. And yeah. So the amplitude will be root 2 is equal to 2a sine kx. So 2a is the maximum amplitude. So I'll just keep it like that. Sine k, this guy would be 2 pi by lambda and x will be 7.5. 7.59. The midpoint is how much? 15. So the maximum amplitude will occur here. This coordinate will be 15 centimeter. So x ka value is 15 centimeter. So root 2 2a sine lambda is 60, 2 pi by 64 and 4 pi by pi by 2. I goofed up something, na? So did I give you amplitude root 2 mm, na? Hmm. 2 pi by lambda. Lambda is 60. Pi by wait.
सर वो k
7.5.
x by 2 आएगा ना वहाँ पे. Your x is 7.5.
Why am I taking center का क्यों ले रहा हूँ मैं? You're right. I'm finding the amplitude of this guy actually. You're right. So this would become pi by 4 then. 2a is 2a. मैं तो midpoint का डाल रहा था. Obviously I'll get 2a only. ठीक है. Basically at x is equal to 7.5 centimeters, amplitude is root 2. So the main thing is this point, that the distance between these two and these two will equal. If you don't figure that out, you won't get the data there. Easy? Got this? So this is what I was saying. Questions are not difficult. It is all basics and all, but you have to be a little intuitive, like, okay, it is happening like this. And the best thing you should know, like, stationary way में कैसा करना है. Every time if you see I'm drawing that loops. So keep it that way. If you do it, try to do it more mathematical, na, you'll get irritated and confused. Next one. Turn in the page. Let's see some questions. Let's get them. These are like standard models.
It should be 20 and 21 now, I think.
ठीक है
Or
ना
it will be
रवि.
19.
ठीक है ना, क्या फर्क पड़ेगा, लिख लेना. For a moment I thought data में कुछ mistake है. Get them. These are easy ones. Just based on the sonometer equation. Answers 19C. Yeah, 19 is C. Look at this thing. He said same metal, matlab rho is same, not mu. Don't get confused. So rho is nothing but mass by A into L. So this is mu by A. So mu is rho into cross-sectional area. So if you have same material, rho will be same, not mu. Now he said wire of length L having tension T, blah blah blah, will vibrate with the fundamental frequency F. Okay. So F is equal to N by 2L root over T by mu. So this is proportional to, he said fundamental frequency is N is 1. Root tension, length is also changing. This is rho into area. So root mu will be rho into pi r square. So this will be root tension, length, and r. Right. So tension became double, length became double, r became double. So yeah, f by root 2. So the numerator becomes root 2 times and denominator becomes 2 times 2 times. So this is 1 by 2 root 2 times. Make sense? Mistake must be that you must have taken mu is same. Get the second one. 20 ka A, yeah, I think so. Twenty ka answer is what? Let's see, string of length 1.5 meter. This is the same as the previous one actually. 1.5 meter with an amplitude 2 mm. So same story there. So 2 is equal to 4 into sine kx. So kx is equal to pi by 6. X is equal to lambda by 12. So this is lambda by 12. This is lambda by 12. That would be lambda by 6. This would be lambda by 3 because the total has to be lambda by 2. And what is the lambda here? Lambda by 2 is 1.5. Lambda is 3 meters. 1 meter. Easy. Next one. Straightforward mains and bit level questions these are. But important, you'll get used to that, get used to that formula. Let's get these three. Did they finish waves in your classes, right? पूरा waves हो गया, Doppler
The
भी हो
wave
गया, they thought
optics, wave optics is also done.
Yes, sir.
कुछ solve किया?
नहीं मतलब other track हो रहा है, but like this one wave से करा है.
Wave optics बहुत important है, highway test topics है ये सब, ठीक है. They did Doppler also?
Yes, sir, they did.
They did ना?
Done wave optics in 2 lectures I got finished.
चलो ठीक है. That is one of the pain point for your seniors actually. Wave optics start. ठीक है. Let's see, let them do what they want. We तो will wrap up the portion by November first week. Advanced portion पहले हो जाएगा. Mains का थोड़ा topics बच जाएगा that we can see in organic physics. रट्टा मारना पड़ेगा formulas. Luckily you guys are actually saved. Last year तो transistors वो सब निकाल दिया था. That used to be a big mess. Your seniors used to hate them. I myself used to hate them. NCERT में they had 2 pages of theory. But unfortunately HSC में अभी भी है. #21 what to do? See, look at the word here. Without there being any other resonant frequency, meaning these two are consecutive harmonics now. Getting it? So 384 hertz and 288 hertz are, and string is fixed at both ends, are consecutive harmonics. That means fundamental frequency or the first harmonic. Or you could have taken it as n and n plus 1 करके solve कर सकते हो. That also would have worked. 384 minus 288. How much is this? 96? 96. So, and this is equal to V by 12. Length कितना दिया? 75. So V is equal to, length is 0.75, 3 by 4. 1.5 into 96. How much is this? 140. 3 by 2,
140.
144. नजदीक तो वही लग रहा है. हाँ. You could have done this, or by chance अगर ये strike नहीं हुआ, you could have done like this thing. So 288 is equal to NV by 12. 384 is N plus 1 V by 12. And eliminate कर लो, you'll get the answer. You can even find the harmonics also. Main idea is that word. There is no other frequency in the middle. They're consecutive frequencies. Next thing, 22. Keep going. Finish it off. Easy though. String of length L is fixed at both ends. It is vibrating in third overtone. मतलब fourth harmonic था. This is the fourth harmonic. So lambda by 2 is equal to L by 4. So amplitude is equal to 2A sine kx. He is saying the maximum amplitude is A. This is sine 2 pi by lambda. X is L by 3. So lambda is L by 2. So if I put L by 2 here, A sine 4 pi by 3. That is anyway sine 60 only, root 3 A by 2. ये क्या था? A chord attached to a vibrating fork. So fork is same. So frequency is same. F is equal to N by 2L root over T by mu. N into root T is constant. Length same tha, string same tha, tension is changing. So 6 into root 36, 4 into root T. 81 newtons. Easy ones. कुछ नहीं, you're just playing with that formula and that equation. There, if you do at least this level of problems, you'll get used to that formula, and then when we go a little tougher ones, so you'll get the hang of it. Any doubts on this? Next one. Basically, this sonometer here. So he's saying the total length of the wire is 114 centimeters. There should be two bridges. So these are the two bridges. They're used to divide into three pieces. So this is one piece, this is one part, and this is one part. So you got three parts here like this. And their fundamental frequencies, meaning each one is oscillating in its own harmonic in the ratio 1:3:4. So find the ratio, like how did the bridges divide them? So they can ask a question like that, find the coordinates of the bridges. If this left side point is x is equal to 0, the right side point is x is 114. Find the position of the bridges. Is the question clear? By putting the bridges, you created three different strings. Sub mein tension same hai, sub mein mu same hai. And all are oscillating in fundamental, matlab everyone got their own single loop. For different frequencies. The fundamental frequencies are 1, 3, 4. Now look at this thing. So f is 1 by 2l root over t by mu. Everything is same except for the length. So L1 is to L2 is to L3 should be in the ratio of 1 by F1, 1 by F2, 1 by F3, which is 1 is to 1 by 3 is to 1 by 4. So if you cross multiply, this will be 12 is to 4 is to 3. Multiply 12 everywhere on the top. So the first length L1 will be 12 by, you know how to take the ratio, 12 plus 4 plus 3, 19 into 114. I think that is coming as 19.6, so 72 centimeters. L2 would be 4 by 19 into 114. This is 24 centimeters. Now be careful. These are not the coordinates. So x is equal to 0. So the first bridge should be placed at x is equal to 72 centimeters. So this length is 72. From here, you have to keep the bridge at a distance of 24, meaning this bridge is at 96 centimeters. Answer is not 72 and 24. And then this is x is equal to 114. So the question is find the position of the bridges. So the bridges should be placed at 72 and 96. What we got is the length of that strings. Clear? Easy one. Next one. Next one. Let's say we have a composite string. 4 mu. This is 9 mu. This is tied to a block M. Let's say this length is L. I will take the length same. I can mess up the lengths also, but he can. So it's a composite string. Made of 4 mu and 9 mu as shown. Find the frequency for the second harmonic. So if standing waves are formed on this system, find me the second harmonic, meaning there is a minimum frequency for which the first time you'll get a stationary wave, 2 times of that. This is the stationary waves on a composite string. Let's get this. So what is the catch here? Whenever you have a composite string, just think about it. This interface which we have, what happens if this interface moves? If this interface moves, it is going to produce a transmitted wave and a reflected wave. Isn't it? So every time that thing moves, it will mess up the wave into two pieces and the whole thing will mess up. So if you don't want that to happen, what should happen? It should not move. That means the interface should always be a node. You're getting it? That is the main catch in composite string. Or kuch nahi hai. So once that becomes a node, you can treat both the strings as two independent things and you can solve. Getting it? So that would be the main important thing in composite strings. For stationary waves to form, because if it starts producing every time, it will produce a reflected and a transmitted wave. You're splitting the wave, you won't get any proper this thing. You won't get a standing wave there. For stationary waves to form, the interface must be a node. Since if it moves, it generates transmitted and reflected waves. There, from now that as a basis, if you start, you'll get the answer now. You can just treat them as two different strings. 4 mu length L, 9 mu length L, both have same tension, same frequency. You're using the same tuning for whatever. Why frequency should be same? Remember, when a wave goes from one medium to another medium, frequency doesn't change. So frequency, but the catch is, we don't know how many loops will form. So V would be N1 by 2L root over T by 4 mu. So for the same frequency, we have N2 by 2L root over T by 9 mu. From here, we get N1 by 2 is equal to N2 by 3. So we have N1 by N2 is 2:3. The meaning of this is, whenever the stationary wave forms, they will be always in the ratio of 2:3 loops. You getting it? So the meaning of this thing is, now look at the meaning of this. So first harmonic. You can try to understand the word of first harmonic, the minimum frequency or the first possibility of a composite string. This is giving you always 2:3 loops. Means you have to have one loop, two loops, three loops. This is your fundamental frequency. When N1 is 2 and N2 is 3, you cannot get anything less than this. You can't create one loop here and 1.5 loop here. No, doesn't make sense. Number of loops always have to be this thing. So the fundamental frequency occurs when N1 is 2. So that is 2 by 2L root over T by mu, 4 mu. This is your fundamental frequency. Or you can keep N2 is equal to 3 to get the same answer. What is the second harmonic in this case? So generally now, we used to think first harmonic meaning one loop, second harmonic meaning two loops. That is not the actual thing. First harmonic meaning the first time you can generate a stationary wave. So second harmonic would be 4 loops, 6 loops. This is the second harmonic. Or you can simply double that, but okay. So F2 would be 4 by 2L root over T by 4 mu. So 2 by L root over T by 4 mu, 2, 4 will cancel. 1 by L root over T by mu. This is your answer, the second harmonic. Is this clear, everyone? So on a composite string, first harmonic doesn't mean one loop. 2 loops and 3 loops. That is your first harmonic. It is like, the red one is saying, you give me 2 loops, I will oscillate with this frequency. The green one is saying, give me 3 loops, I'll oscillate with this same frequency. So that 2:3 ratio, they both are okay with the same frequency. They both are coming to an agreement with that frequency to keep the interface at rest. I hope this is clear. So first harmonic doesn't mean first one loop. First harmonic meaning the minimum frequency or the first frequency for which the stationary waves form. Clear with this? No. Let me give you a homework problem. Try this and come. Next class we'll discuss. So we have a stationary wave. So the equation is y is equal to 2a sine kx cos omega t. And let's say amplitude is very small. So this is x is equal to 0. This is x is equal to lambda by 2. Find the total energy of one loop. In case you forgot, remember this thing of tension dou y by dou x whole square dx. This is valid for everything. This I didn't derive for progressive wave. If you remember this thing, how I derived, I never derived this for progressive wave. I just took a random string. I took a random elongation, and I proved this. You're getting it? We never proved that for that thing. It is valid for everything. Again, this is for a segment. This is for a small piece. मुझे total loop का चाहिए. Again, kinetic energy of the segment is half dm. You can take mu and all whatever data you want. Dou y by dou t whole square. Try this as a homework question in the next class. Okay, so with that, we'll wrap up for the day. So next class, when we catch up, we are going to continue more. We did this composite string. We are going to do free end ka thing, and then we'll do a general equation of a stationary wave. Stationary wave ka general equation will actually look like this: 2a sine kx plus phi 1 sine omega t plus phi 2. So that's a more general form of a stationary wave. So we will see what this thing means. And then we'll see the differences, energy stored in a progressive stationary wave. So this thing I gave you this, so it's the same thing. And then we will write the differences between progressive wave and stationary wave, just to summarize. Mostly next class, my first half, we will finish off stationary waves, and then we'll start off with sound waves. Sound waves ka thing will look similar then, but sound waves mein beats and Dopplers are more important. Okay, so with that, we'll wrap up for the day. So I'll see you guys again next week. So any doubts, anything, stay back and ask, or else you free to leave. So take care, stay safe.